So this section is called sequences itself. It's kind of like a function with a little bit twist of a definition. Okay, so a sequence in math is things that go one after another, like a sequence, like 4, 5, 6, 7, 8. They go one after another. Okay, so the precise definition of a sequence is this one here: is a function whose domain is a set of all positive integers. So remember, all positive integers essentially saying is n is one or more, essentially when it comes to that. So it's never negatives. Okay. Now, to define what an actual sequence is, it's pretty straightforward. Just start with a little example. So let's suppose that we have this function here, right? F of x equals to 3x plus x plus 3. Okay. Now, to convert this into a sequence notation, all we're going to do is instead of x, we're going to write it in terms of n in this case. So it's going to look like this now. Okay. Where again, n is from 1 to infinity, right? Now it's not negative in itself. Okay. So for instance, if I plug in 1 in for n, so f of 1. Well, f of 1 is 1 plus 3 gives you 4, right? And if I go f of 2, that's 2 plus 3 gives you 5, right? So from there, we're going to keep. So how this works is, when it comes to sequence, well, this we call is the first term of the sequence. And this will be the second term of the sequence. And you guys kind of get the pattern. F of 3 would be the third term, so that would be 6. So how we want to write a sequence itself is, well, we don't actually write the actual numbers. We say the actual answer. So we say 4, 5, 6 will be the first term, second, third, and third term, right? Now, again, to abbreviate that even more, we say the first term is called a sub 1. The second term is called a sub 2, a sub 3, and then dot, 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 a sub n. So essentially, if you notice, this is the numbers we plug into the function to get the values out. And again, the term itself, so the sequence is made up all of the answers once you plug in the numbers themselves, okay? So that's called a sequence, and this is the actual portion when it comes to a sequence portion like that, okay? So the last and final thing when it comes to this conversion itself, so we started from here, right? We went to there. So now notice this a sub 1, a sub 2. The last version was, well, we don't write it as f of n. We write it a sub n is now equal to n plus 3. And that is an entire sequence function itself. So no f of x, it's all in terms of n and the a sub n terms. So again, if I want n equals 1, I literally just plug in n equals 1 into all the entire equation, and we get exactly that, right? 4. That is the first term in our sequence. Okay? So let's just try an example so you can see how this will work out. So let's find the first 5 terms of the sequence. So we want a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5, right? The first 5 terms of the sequence. And that's just saying we're going to plug in 1, 2, 3, 4, and 5, and n, and see what we get out, right? Just like a function. So if I plug in 1, 3 times 1 is 3, minus 4 gives you negative 1. 2 times 3 is 6. 6 minus 4 is 2. 3 times 3 is 9. 9 minus 4 is 5. And so forth, right? So 4 times 3 is 12. Minus 4 is 8. And then finally, 5 times 3 is 15. Minus 4 gives you 11. Just like that. So literally it's just like a function. We just label it in our different type of notation when it comes to sequence. Okay? And same thing applies for a piecewise function, right? So let's say we want a sub 1 again, 2, 3, 4, and 5. Okay. Now this is going to be careful, right? Because since it's a piecewise function, it's going to be one or the other, not both. So first off, a sub 1. So 1 is odd, hopefully, right? It's not even. So if n is odd, we do this. So negative 1 to the first power gives you negative 1, right? That's our first term. Let's go next one. A sub 2. Well, that means n is 2. That's even. So 2 squared gives you 4, right? 3. So n is odd, right? It's 3. So it'll be negative 1 to the third power. That's going to be a negative 1. Next one, 4. So 4 is even, so it goes here. 4 squared gives you 16. And finally, 5 is also odd. So negative 1 to the fifth power is, again, negative 1. So hopefully it's not too bad, right? It literally is just a function. We just have different notation based on that kind of stuff. Okay. But the real good stuff when it comes to sequences and the stuff you'll see more about, more precisely, is something called recursion functions, which is huge when it comes to any engineering courses you're going to be if you guys go into that part of stuff. So a recursion sequence is a sequence that involves the terms before it or before the preceding ones. Okay, which means is if you get one wrong, you get the rest of the sequence wrong as well. So it's very, very important when it comes to that. And believe it or not, this goes into electrical engineering and mechanical engineering dramatically when it comes to that. So here's an example of what a recursion sequence looks like. So notice it's a sub n, and notice it's n minus 1 and a sub 1. So when it comes to recursion sequences, we'll always give you the first or the first couple terms because it depends on those type of stuff itself. Okay, so we want to find the first 5 terms. So they told us the first term is 2, right? They just told it right off the bat. So next we want our a sub 2. That means we plug in 2 everywhere we see an n, right? So a sub 2, we're going to have 3 a sub subscript 2 minus 1 minus 4 times 2, right? All I'm doing is plugging in 2 everywhere I see an n, and I just simplify. Well, what's 2 minus 1? 1, right? That's going to be 8. Now, this is what I mean by, a recursion sequence, it depends on the previous ones. Notice, in order to get a sub 2, I first need to plug in or find a sub 1, meaning I plug in 2 where I see a sub 1. So my a sub 2 term is 3 times 2 minus 8, because that a sub 1 term was given to me to be 2. Now notice on the next term it's going to be the same thing. It's going to go back and back and back and forth like that. Okay, so if we keep going, this would be 6 minus 8, negative 2. So a sub 2 is negative 2. Okay, and we keep going. So a sub 3. So a sub 3 is going to be 3 a sub 3 minus 1 minus 4 times 3. So this is going to be 3 times a sub 2 minus 12, and a sub 2 was negative 2. This is 3 times negative 2 minus 12, so it'll be negative 18, and it goes on from there. So a sub 4 would be 3 times negative 18 minus 4 times 4, and then a sub 5 will be 3 times whatever and this ends up being itself. Okay. So why don't you guys try B? It's a little bit longer one, but I think you guys can try it. So B is here, so they give you a sub 1, a sub 2. Go ahead and do the rest of it. Find a sub 3, 4, and 5 respectively. So 3, 2, 1, pause. Okay, so hope you guys tried it. So let's try a sub 3. That's going to be 4 times 3 plus a sub 3 minus 1 minus 3 a sub 3 minus 2, right? I'm just plugging it everywhere I see it. This is 12 plus a sub 2, and a sub 2 was 2, minus 3 a sub 1, which is 1. So a sub 3 is going to be the addition, subtraction, all this. So it's going to be 14 minus 3 is 11. Okay. So a sub 4 is going to be 4 times 4 plus a sub 4 minus 1, so a sub 3, that's 11, minus 3 times a sub 2, which is 2. So it'll be 16 plus 11 minus 6. What is that, 21? And then finally, a sub 5 is the same process, right, when it comes to it. It can be 4 times 5 plus 21 minus 3 times 11 when it comes to it.